Russian University in Bangladesh. This study focuses on understanding how scabies spreads in a population and how different control strategies help from controlling and reduces our transmission rate. Before I begin, I want to share our introduction of the problem and motivation behind our study, and I will discuss about our methodology, objective methodology, and then I will explain the result section, mathematical analysis including sensitivity analysis, stability analysis, and scenario analysis. And finally, I will conclude our key findings and our future works and questions answer as well. Now I introduce my topic. Scabies is a highly contagious parasitic disease that are caused by Sarcoptes scabies. The mite is through a small neck, you cannot see it by naked eye. The approximate size of the mite is 0.4 millimeter, and sometimes it is called pitch mite because of its ability to severe pruritus on roots, and it spreads in a new way. First one is direct transmission, and another one is indirect transmission. Direct transmission happens when we are close contacts, human or skin to skin, and another one is indirect transmission. Indirect transmission happens when we are affected through environment of human. Here you see life cycle of scabies. Now we go to the epidemiology. Epidemiology is the study of the disease, how it spreads in the population, and who are affected throughout it. In a study, who is treated, more than 200 million people are affected throughout it and at any time, and more than 400 million people are cumulatively in a year. It is a significant public health problem in Bangladesh, including the Russian University, and due to the overcrowding and limited access to healthcare. In Russian University, close living and learning environment can facilitate transmission, leading discomfort, sleep disturbance, and academic distraction. We collected data from our Russian University Medical Center, and we observed data 1355, and we confirmed that we are confirmed that the rates of STDs are 250. And we see our objective. Our main objective is the formulate a mathematical model for describing the how transmission dynamics and within the Russian University population we perform here the system properties and solution as well as stability, sensitivity, and scenario analysis of the model. We identified the method parameters influencing the basic introduction of the RNA and assess the long-term dynamics of scabies transmission under various conditions. We evaluate here the effectiveness of different intervention strategies including transmission control, treatment, and vaccination. Now see our methodology here the model diagram. We formulate a SCIR type model with vaccination. Here as the susceptible population is the infected, exposed, and I is the infectious, and I is the recovered. Here is all of our model parameters. And to see our model equation, we get it by ordinary differential equation, where S is the Bayesian susceptible and S is the Bayesian susceptible. So when we sum all of the components, then we will get the total number of the population. Now see the reproduction number. Reproduction number is the average number of secondary infection produced by one infected individual in a completely susceptible population. Here you see the graph. The population are continuously increasing. That means why it is happening? When our reproduction number is greater than 1, that time the scabies diseases are spread out in the population. That's why the population are increasing. And when the reproduction number is less than 1, that time the diseases are diverged in the population. That's why population are continuously decreasing. And now see the result section. This graph shows the mathematical model. It's from real data from our Russian University. Here the red dotted line represents our daily observed cases, and the blue solid line represents the fitted model which we get by least square method, and the blue alignment represents the accuracy for our epidemic model, and we see the disease-free equilibrium versus disease endemic equilibrium. This graph demonstrates the sensitivity of the reproduction number. We see the trajectory length or trajectory plots of this plane comes close to 0 and the red dotted point are in 0. That means there is no disease between exposed and infectious. That's why in the case the reproduction number is less than 1, and when we see the red dotted point are in the population, that means the diseases are in the population, that means exposed between infectious. The disease endemic equilibrium when R0 is greater than 1. In this case, SKBs will persist in the population. And you see this is analysis. It's for mainly the different parameters how more important on impact of our model outcomes. Here you see 6 parameters. Equal relation between beta 1 and R0. We see that the partial rank correlation value is close to 1. That means there is a strong relationship between beta 1 and R0. That's why the value of KFCC is 0.890, and beta 2 and sigma has the moderate correlation between them, between R0 and epsilon and epsilon, gamma and mu has the negative correlation between as well. Now we see the binary plot, which is the summary of the sensitivity analysis. This is mainly for which parameter is sensitive or more important for our model parameters. Hence, we see the different types of graph. We apply different types of treatment. As you can see, if we increase our treatment rate, that time infections individuals are increasing, and control plot or treatment showing the same thing as well. And now we see the similar analysis for transmission rate, that means beta parameter. Here we see different types of graph. Each of the graph for each of the different types of beta value. Here we see Gaussian plot with box plot. Both shows that spread and the center frequency. And now we see if we increases our transmission rate, that time the susceptible vaccination population are continuously increasing, and the infected and exposed population are decreasing, and the recovered population are slightly decreasing. Now we see the similar analysis for recovery rate and treatment rate. When we increases the treatment rate or recovery rate, that time the susceptible vaccination population are increasing, and the infected are exposed population are slightly decreasing, and the recovered population are increasing. Now we see the scenario analysis for recovery rate, vaccination rate. When it increases, obviously the vaccination population are increasing, and the infected and exposed population also decreasing, and the recovered population slightly decreasing. And now we see I will conclude. It's a non-linear mathematical model was formulated to investigate the Scabies dynamics. The basic reproduction number governs the persistence and the elimination of scabies. The scabies will eradicate from our university if the R0 is less than 1, and the disease will persist. The R0 is greater than 1. The findings from our analysis may assist public health professionals in implementing the most effective strategies to control scabies outbreaks at Russian University, Bangladesh. In future, I plan to incorporate each structure modeling and real-world epidemiological data to enhance accuracy of prediction and guide public health decision making. Here, all of our references. I would like to express my sincere gratitude to my supervisor, Dr. Abu sir, for his pedagogical guidance and support throughout this research. And I wish to express my appreciation to Russian University Medical Center for providing us that physical data and which plays an important role for our research. And finally, I would like to thank the conference organizing committee for wonderful event and giving me opportunity to present my research.
Thank you very much.